Hey guys, welcome back to another episode of my channel. My name is Keika. I'll be going over Campbell's biology textbook, chapter by chapter, section by section. This video will be going over Unit 1, the chemistry of life. Chapter 2, the chemical context of life. Okay, so let's scroll down to the key concepts. And I wrote the subheadings here as well. So we'll be going over concept 2.1, matter consists of chemical elements in pure form and in combinations called compounds. Concept 2.2, an element's properties depend on the structure of its atoms. Concept 2.3, the formation and function of molecules and ionic compounds depends on chemical bonding between atoms. And concept 2.4, chemical reactions make and break bonds. And now going to the learning objectives. So after studying this chapter, you should be able to do the following. Describe matter, chemical elements, and chemical compounds. Use examples to illustrate how the structure of an element's atoms determines its properties. Identify and describe the types of strong and weak chemical bonds and use examples to show how bonds affect molecular shape. And given an example of a chemical reaction, describe its meaning in words. Okay? So let's get started with concept 2.1. Okay. Concept 2.1. Matter consists of chemical elements in pure form and in combinations called compounds. Organisms are composed of matter, which is anything that takes up space and has mass. Matter exists in many forms. Rocks, metals, oils, gases, and living organisms are a few examples of what seems to be an endless assortment of matter. So I wrote organisms are composed of matter, which is anything that takes up space and has mass. Elements and compounds. Matter is made up of elements. An element is a substance that cannot be broken down to other substances by chemical reactions. Today, chemists recognize 92 elements occurring in nature. Gold, copper, carbon, and oxygen are examples. Each element has a symbol, usually the first letter or two of its name. Some symbols are derived from Latin or German. For instance, the symbol for sodium is Na, from Latin word natrium. A compound is a substance consisting of two or more different elements combined in a fixed ratio. Table salt, for example, is sodium chloride, NaCl. A compound composed of the elements sodium and chlorine in a 1-to-1 ratio. Pure sodium is a metal, and pure chlorine is a poisonous gas. When chemically combined, however, sodium and chlorine form an edible compound. Water, another compound, consists of the elements hydrogen and oxygen in a 2-to-1 ratio. These are examples of organized matter living in emergent properties. A compound has characteristics different from those of its elements. Okay, so here I wrote element, a substance that can't be broken down to other substances by chemical reaction. There are 92 elements that occur in nature. Gold, copper, carbon, oxygen are examples. Compound, a substance consisting of two or more different elements combined in a fixed ratio. So salt and water as examples. And I wrote, a compound has characteristics different from those of its elements. The elements of life. Of the 92 natural elements, about 20 to 25% are essential elements. Are essential elements that an organism needs to live a healthy life and reproduce. The essential elements are similar among organisms, but there is some variation. For example, humans need 25 elements, but plants need only 17. Just 4 elements, oxygen, carbon, hydrogen, and nitrogen, make up approximately 96% of living matter. Calcium, phosphorus, potassium, sulfur, and a few other elements account for most of the remaining 4% or so of an organism's mass. Trace elements are required by an organism in only minute quantities. Some trace elements, such as iron, are needed by all forms of life. Others are required only by certain species. For example, invertebrates, animals with backbones, the element iodine is an essential ingredient of a hormone produced by the thyroid gland. A daily intake of only 0.15 milligrams of iodine is adequate for normal activity of the human thyroid. An iodine deficiency in the diet causes the thyroid gland to grow to abnormal size, a condition called goiter. Consuming seafood or iodized salt reduces the incidence of goiter. Relative amounts of all the elements in the human body are listed in Table 2.1. Okay? So this is the list of the elements in the human body, which are oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. And just a heads up, if you're going to nursing school or medical school, you're going to need to memorize these eventually. So it's up to you whether you want to memorize this now or later. Some naturally occurring elements are toxic to organisms. In humans, for instance, the element arsenic has been linked to numerous diseases and can be lethal. In some areas of the world, arsenic occurs naturally and can make its way into groundwater. As a result of using water from drilled wells in southern Asia, millions of people have been inadvertently exposed to arsenic-laden water. Efforts are underway to reduce arsenic levels in the water supply. Okay, so for the elements of life, I wrote 20 to 25% of the 92 elements are essential elements, that being elements required to survive, grow, and reproduce. Some similarities in elements, some variation in needed amounts, such as humans require 25 elements while plants require 17 elements. 4 elements make up approximately 96% of living matter: oxygen, carbon, hydrogen, and nitrogen. Calcium, phosphorus, potassium, sulfur, and other few elements account for the remaining 4. Then trace elements, elements that are indispensable for life but are required in extremely minute amounts, such as iron and iodine. And I just wrote the elements of the human body that we just said earlier. And some naturally occurring elements are toxic to organisms, such as arsenic. Okay. Case study. Evolution of tolerance to toxic elements. Evolution. Some species have become adapted to environments containing elements that are usually toxic. An example is serpentine plant communities. Serpentine is a jade-like mineral that contains elevated concentrations of elements such as chromium, nickel, and cobalt. Although most plants cannot survive in soil that forms on serpentine rock, a small number of plant species have adaptations that allow them to do so. Presumably, variants of ancestral non-serpentine species arose that could survive in serpentine soils, and subsequent natural selection resulted in the distinctive array of species we see in these areas today. Serpentine-adapted plants are of great interest to researchers because studying them can teach us so much about natural selection and voluntary adaptations on a local scale. So that's a serpentine plant. These are plants growing on serpentine soil which contain elements that are usually toxic to these plants. The insects show a close-up of serpentine rock in one of the plants, a tuberone mariposa lily. This specially adapted species is found only on this one hill in Tuberon, a peninsula that juts into the San Francisco Bay. Interesting. Okay, so for my notes, I wrote some species have adapted to environments containing elements that are usually toxic, such as serpentine and plant adaptation. And natural selection resulted in variant species that could survive in serpentine soils. And I'm just gonna write learning about such adaptations can help us learn more about natural selection and evolutionary adaptations on a local scale. Okay, so that's it for this video. We finished concept 2.1. It was kind of a short one, but we'll be going over concept 2.2 next video. Let's take a quick glance at what we'll be going over. We'll be going over subatomic particles, atomic number and atomic mass, isotopes, radioactive tracers, radiometric dating, the energy level of electrons, electron distribution and chemical properties, and lastly, electron orbitals. So it seems like we'll have a little bit of a longer video next time, but it'll be okay. It'll be okay. I'll see you guys next time. Bye.